Have you ever been stuck on a math test, just burning precious time calculating the sides of a right triangle? Well, if that's you, then you're in the right place. We are about to unlock a super powerful shortcut that's going to save you a ton of time. We're talking about Pythagorean triples. Look, we all know the Pythagorean theorem, right? A squared plus b squared equals c squared. It's a classic, it always works. But let's be honest, sometimes it can be a total drag. When you're up against the clock, all that squaring and then trying to find the square root, it's just slow and tedious. So check this out. You get a problem with legs of 15 and 20. You have to write it all out. Okay, 15 squared, that's 225. 20 squared is 400. You add them up, you get 625. Now, what's the square root of 625? You can probably figure it out, but it takes a minute, and there is a much faster way. And that right there is the big problem. The theorem is great, but it often leaves you with messy decimals or big numbers you have to find the square root of. It just eats up your time. But what if I told you there is a way to completely bypass all that calculation on certain problems? The secret is something called a Pythagorean triple. These are these special, almost magical sets of 3 whole numbers. No decimals, no fractions, just clean, positive integers that fit the formula perfectly. You can think of them as cheat codes or pre-solved problems. If you know them, you can just spot the pattern and boom, write down the answer. So how does this amazing shortcut work? It's actually really simple. All you have to do is memorize the 3 most common triples. That's it. Get these 3 little families of numbers locked in your brain and you're going to start seeing them pop up everywhere. First up, we've got the most famous one of all, the king of the triples, the 345. 3 squared plus 4 squared equals 5 squared. It's beautiful. It's simple. This is the one you're going to see more than any other. Next on the list, we have the 512-13 triple. Now, this one's a little less obvious, but it's just as important. 5 squared is 25, 12 squared is 144, and yep, that adds up to 169, which is 13 squared. And the last of our big 3 is the 8-15-17 triple. This one's a bit more obscure, but man, it is a lifesaver when it shows up on a tricky test question. If you can remember this one, you are way ahead of the game. So here they are, all together now. These are the 3 core families you need to know. Now, there is one absolutely critical rule you have to remember. The largest number in any of these triples, the 5, the 13, the 17, is always the hypotenuse. Always. That's the side opposite the right angle, and it is the key to using these correctly. Okay, so just memorizing those 3 sets is great, but the real power, the real magic, happens when we learn how to scale them up. You see, these triples don't just work for the base numbers. They work for any similar triangle that has the same proportions. Let me show you what I mean. The process is incredibly simple. You just take a base triple, like our old friend 345, and you multiply all 3 numbers by the exact same amount. So for example, if we multiply everything by 10, we get a brand new, totally valid triple, 30, 40, 50. A triangle with legs of 30 and 40 will always have a hypotenuse of 50. No calculation needed. See how cool that is? All right, enough theory, let's put this into practice and see just how much time this can actually save you on a real problem. Hey, remember this problem from the beginning? The one that had us doing all that squaring and square rooting? Let's tackle it again, but this time, let's do it the smart way. So here's the thought process. You look at the 2 numbers you're given, 15 and 20, and you ask yourself, what's the biggest number that divides into both of them? Well, it's 5. So you divide both numbers by 5. 15 divided by 5 is 3, and 20 divided by 5 is 4. And right there, a light bulb should go off. You've got a 3, 4, something triangle. We know that's our 3, 4, 5 triple. So the missing piece of the pattern is the 5. And there it is. The missing side has to be the 5 from our pattern times our multiplier of 5, which is 25. The hypotenuse is 25. Done. In like 5 seconds with 0 heavy calculation. That's the power of this shortcut. Okay. Let's try one that's a little bit trickier. This time, they give us the hypotenuse, which is 39, and one of the legs, which is 15. We have to find the other leg. But don't worry, the process is exactly the same. So first step, what's the common factor for 15 and 39? It's 3. Okay, let's divide. 15 divided by 3 gives us 5, and 39 divided by 3 is 13. So what does that look like? We've got a leg of 5 and a hypotenuse of 13. Wait a second. That's our 5, 12, 13 triple. The missing leg in the gaze pattern is 12, so all we have to do is scale that up by our factor of 3. 12 times 3 is 36. And that's our answer. The missing leg is 36. So our full scaled-up triple is 15, 36, 39. See? We solved it in seconds, just by recognizing the pattern. Now, this all seems pretty easy, right? But there is one major, super common mistake that students make all the time. Let's talk about it so you never, ever fall for it. This is what I call the hypotenuse trap. Imagine a problem gives you a leg that's 3 and a hypotenuse that's 4. Your brain is going to see those numbers and just scream, it's 3, 4, 5, the other leg is 5. But stop, wait a minute. Remember that golden rule, the hypotenuse has to be the longest side. Can you have a leg of 5 that's longer than a hypotenuse of 4? No way. It's impossible. In a case like this, the triple shortcut doesn't apply, and you'd have to go back to the old a squared plus b squared equals c squared formula. So you might be sitting there thinking, okay, this is a really cool test trick, but do people actually use this stuff in, the real world? And the answer to that is a huge, resounding yes. Is this whole shortcut just about acing your geometry final or getting a few extra points on the SAT? Nope, not at all. This simple little math pattern is actually a fundamental tool for the people who literally build the world around us. In construction, this is known as the 3-4-5 rule. Think about it. When carpenters are framing a house, they have to be absolutely positive that the walls meet at a perfect 90-degree angle. They don't pull out some giant protractor. They use a tape measure. They'll measure 3 feet down one board, 4 feet down the other, and if the diagonal distance between those 2 points is exactly 5 feet, they know for a fact that the corner is perfectly square. It's a real-world application that relies completely on this ancient math triple. So the next time you see a right triangle problem, just pause for a second. Before you start punching numbers into a calculator, look for the pattern. By mastering these triples, you're not just memorizing some random facts, you're actually learning how to work smarter, not harder. So the real question is, how much time are you going to save now that you know the secret?